Hi all, welcome to Lab 2 in JASP doing descriptives and visualizations. And this is all about communicating the data and the information from the data set to your viewer, your reader, your colleagues. So we're going to summarize categorical and continuous variables and create graphics to communicate the results. We're also going to evaluate an assumption of the data called Univariate Normality, which is typically required for the parametric techniques we will be using later in the series. The materials you need are linked in the description, namely the survey dataset called Survey 2024 Lab 2 and an example write-up. So let's get started. Opening up JASP, you want to navigate to wherever you put the survey file. And even though we're opening a SPSS file, JASP is pretty good at figuring out what everything is, as long as it was correctly coded in the SPSS file. So you'll see that the ID is set as a categorical, sex, marital, child, all of our categorical variables are set correctly. Age and smoke number are set as scale, so that's good. And at the very end of this file, we have the total scale scores are already computed here. So that's good. And what we want to do is get some descriptives. We're going to start by getting the descriptives for the categorical variable sex. And we can edit right here. So that it also appears on our output. Now notice that the default is to give us the mean and standard deviation, the min and max. But for the sex categorical variable, this does not give us any information we can use. We already know that males are coded as 1, females are coded as 2, so none of this really pertains to a categorical variable. So first thing we're going to do is turn off some of this information we don't need. We don't need mean, standard deviation, min or max, and we can fold that back now. We do want tables. So folding down the tables, select frequency tables. And this is the information we want for talking to our reader or our audience about the makeup of the sample in terms of gender. We had 185 male participants, 254 female participants, and the percent of the whole sample of what they represented. We can get a pie chart of this by folding down basic plots and going to pie charts. So now we have males and females, and if this was the whole, this much is female and this much is male. Now, pie charts have a difficult time really conveying good information, so you want to make sure that when you do use one, it's really giving information that you're trying to explain to your reader or your audience, not just another graphic. What is typically more used is going to be a bar chart. In JASP, this is called a distribution plot. So we'll add that, and here we have males and females as a bar chart. Good. I'm going to fold this one away and get a new descriptives panel, and we'll just go ahead and do all the other categorical variables. So I'll get not only the sex variable, marital, child, education, source, and smoke as well. And that's all my categorical variables in here. Again, it's giving me information that's not helpful, so I'm going to turn off mean, standard deviation, and min and max. And then I can just have it not so messy, and because it can get confusing when you have a lot of output to fish through to get the information you want. And here we can see that there's a missing response for the child variable and 17 missing for source and 3 for smoke, which means 17 respondents decided to not answer that question, the question about what is a major source of stress for you. That's all. And we want our tables. And here we have that information. Again, the males and females like before. How many people are in each of these different relationship statuses. And in this, the percent and the valid percent are the same. That's because there's no missing values. When we come down to the child, do you have a child at home question, because there's one that's missing and that one respondent represents a portion of the whole, then these numbers are slightly off. And it's going to depend on what are you trying to convey and why. Because sometimes knowing how many people did not answer a question is something that's important to the research you're doing. But for what we're doing here today, I'm reporting just the valid percent. Valid percent means of those who responded to this question, 42.2% of those who responded said yes, they have a child at home. And 57.8%, because you round to the tenths place, 57.8% of those who responded, which is 253 people, said no, I don't have a child at home. We have the highest education completed, so how many and what percent of the whole they represent, and then the major source of stress. Again, because there's 17 missing, I'm going to use just those who responded to the question. And frequencies for do you smoke or not. And the way this looks in the write-up is when we have a categorical variable, we are reporting how many and what percent of the whole for each level of the categorical variable. I had this many male and what percent of the whole that represents, and this many female and how much percent of the whole the females represent. Instead of a pie chart, a good chart to use for the categorical variables is the bar chart, which is going to be called distribution plot in JASP. Now we have males and females. Here on relationship status, marital status, notice how all of the levels are jammed together. That's unfortunate because there's not a whole lot we can do about that. We have very limited editing ability on the graphics in JASP. Like I can change this title down here to marital status. And I can do kind of similar on the y-axis, but there's not a whole lot more I can do. Advanced just gives me some options, but not really anything I can do to help that x-axis and those levels of the variable. So that's unfortunate. But you can save these, any of the images you want to use in your write-ups, you can save them by using Save Image As, and then just saving it to wherever you're going to keep your materials for your write-up. I'm going to get a new descriptives section in my input panel here. And for this one, we'll just do age and perceived stress. So I want my age variable, And I want total perceived stress, which is way at the bottom, TP stress. Have them in my variables box. And now that table is helpful. I do want the mean. I do want the standard deviation. In fact, the min and max are helpful too. I know that the age range of the sample was from 18 to 82 years old, with average age being 37.4, about 37 and a half years old, and a standard deviation of about 13 years. What we can also look at is skewness and kurtosis. These are values that tell us a little bit about the distribution. Positive skew numbers mean that it might have a positive lean, have the tail in the positive side. And we can see that when we pull the histogram for this. A negative kurtosis means that the tails are kind of chunky. They're not smooth tails. A positive kurtosis means it's really peaky in the middle of the curve. It's really just peaky right in the middle. And if we had a negative skew number, it would mean that the tail on the negative side of the scale is very long. We have some outliers on the negative side or on the lower side. But let's take a look at the basic plots here. For a continuous variable, distribution plot in JASP is a histogram. So we can see the histogram for age has that positive skew going on, which we kind of expected when we had a positive skew number up here in the table. And the kurtosis being negative, it's probably getting hit by how chunky this is. Like it's not a nice smooth curve there. And total perceived stress has this curve, except it's really peaky in the middle. That's the kurtosis number. And it does lean a little bit on the positive skew. Not bad though. I would say that's getting close to normal distribution. So these are things we can look at graphically to help explain what the data looks like. Another graph we can get here it's in customizable plots, is a scatter plot. Because both age and total perceived stress are continuous, we can see if they are related to each other. So here's the scatter plot. I'm going to turn off some of this extra information that we don't need. So I'm going to turn off the regression line, and I'm going to turn off the graph above and the graph to the right for now, just so that we can see the scatter plot. There we go. So we have total perceived stress and age, and it does not look like there's any kind of relationship there. So when we want to look at the other continuous variables, let's do that. We'll take a break on this one and leave it here. I'm going to fold it back and get a new panel. And here we'll do all continuous variables. And I'll hit enter. So I'll pull over age. Let's go down to the totals from total optimism to total perceived control of internal states, all of those. And like before, we have some good information right here in the table already as far as mean and standard deviation, min and max. Let's go ahead and get skewness and kurtosis to help look at that normal distribution. We're hitting some negative skews, really positive skew on total negative effect. And we'll get the distribution plots. So that's going to be the histograms for these. And we're able to see those. So a very negative skew there for total optimism. Negative skew. Getting close. Other than inspecting the histogram and looking at the skewness and kurtosis values, the other way we evaluate the normality of a continuous variable is with a normality test. And the one that JASP gives us available is the Shapiro-Wilk test. So if I turn on that, it adds information into our table here. I'm going to close out that so we can just see the table. So Shapiro-Wilk test and the significance value. And that's really what you're looking for. On the normality test, you're just looking for if they're significant or not. A significant normality test means there is a violation of normality. That's what you got. So all of these values for the significance of the Shapiro-Wilk are significant. In other words, they're all less than 0.05. So according to Shapiro-Wilk's test, all of these continuous variables violate univariate normality, which is a thing because our parametric techniques kind of depend on a normal distribution of the variables. So it's good to know what you would do. I mean, some of them are not seriously violating like that. I would still work with, but this negative affect, that's like, there's no normal about that. So you're doing a visual inspection and you are telling the reader in your write-up what you saw, and it's okay. You can claim that you feel that this is, pretty normal. It seemed pretty normal except for some outliers on the lower area. Or you can say, no, definitely I felt like this was negatively skewed and it violated Shapiro-Wilk's. The thing of Shapiro-Wilk's test is that it's sensitive to large samples. What is a large sample? According to Shapiro-Wilk, pretty much anything over 100. So we have over 400 sample size. That means Shapiro-Wilk is going to be rather sensitive to non-normality in this data. But let's take a look at how we talk about that in the write-up. So you let the reader know that you evaluated normality. You tell the reader how you evaluated normality. And you tell them what your normality test said. You don't need the numbers for it, but you need to let the reader know if it was significant or not. Okay, that's about it in JASP. Let's take a look at the write-up here. We have, when we are explaining a categorical variable, you have how many and the percent of the whole for each category or each level in the categorical variable. And when you have a continuous variable, you want to give the reader the mean and standard deviation, at least. When you have a graphic that will help explain the data, you would let the reader know right away that there's a figure for them, and those are going to be in the appendix. Same thing here when we're working with categorical variables or we're working with continuous variables. And then here we say, while perceived stress and age were not related, and that's our scatter plot, there seem to be differences in perceived stress depending on one's gender, and that's in figure 5. I can go down to that. So there's our scatter plot, and here is a box plot of total perceived stress for males and females. Let's see how to do that in JASP. So going back to our inputs here, I'm going to get a new one. going to call it stress and gender. I want total perceived stress, and then I'm going to split by gender. So take the sex variable and put it here in the split. So now we know the stress for females, 27.4 on average. The stress for males, 25.8, because you round to the 10th place for males on average, and the standard deviation. But what we want is the box plot. There we go. In customizable plots, and we have the males and the females. So the middle line is the median, that middle dark line, and the dots that you see are going to be considered outliers. But 50% of the sample is in the rectangle. So that's another graph that might be helpful when you're talking to your reader or your audience about the impact of stress across genders. So it depends on what you're looking at specifically in your research. Okay, so now we have all of this. We have the categorical sex, descriptives categorical, age and perceived stress to start off our continuous, and then the other continuous variables, and we made a box plot with just stress and gender here. We want to save these results, and you can do that by exporting. Just make sure you know where it is. Results, Lab 2. And we are done with our JASP work. Okay, we got a lot done there. We were able to just open the SPSS file in JASP, so that's nice that it's easy to just take an SPSS file and open it up. We didn't have much cleaning we had to do, so that's good. And all we needed was to describe the categorical and continuous variables, get the information we need for the write-up, and pull some graphs to see which ones we want to use in the write-up to help convey the information. Make sure you saved your results in the HTML file, and I'll see you in the next lab.